All right, so in that first one, so what do we do? What do we do for inverse? Notice there's three, number 1, number 2, number 3, inverse questions, exactly how it'll be on the actual exam. So how do we handle inverse? There's 2 steps to finding an inverse function. Step number 1, switch or invert x and y. So remember, you get a 3x5 card. I would make the 3x5 card, even right now, on a separate piece of paper. You can start scribbling the things you would want on your 3x5 card. Remember, make the card as you do the practice exam. As you do the practice exam, which we're doing right now, you want to, because that's everything that'll be on the real exam, and anything you need, put it on your card. So one of the things would probably be the steps for finding an inverse function. So step 1, switch x and y. That comes from the idea of invert, huh? Switch or invert x and y. Now, I don't see y. Where's the y? F of x. Yeah, we've talked about that a few times, huh? Functions are y, aren't they? F of x, g of x, h of x, those are y. So those are going to switch. So that's going to become x on the left and y on the right. So far, so good? I switched x and y became x, and x became y. And then step number 2, solve for y. Right? Step number 2, solve for y. So here we have an equation, an equal sign, a left side and a right side. And y is saying, I want to be alone. Please get rid of that plus 7 and get rid of that third power that are on me so that I can be alone on my side of the wall. Huh? So what do we do first to start getting y alone? Subtract the 7. That's right. So we'll come in here and we'll go minus 7. Cancels out. So we get y cubed is x minus 7. And what are we going to... Let me put that there like that. Now what are we going to do to get rid of that third power? What's the opposite of a third power? A third root, right? Roots are the opposite of powers, right? You can see all the answers over there have third roots, so it makes sense. So a root is exactly the opposite of a power. So a third root, the opposite is a third power. Or a third power opposite is third root, either way. They're opposites of each other. So I'll say, okay, I'll just come in here and go third root over. Now careful, when you do it, remember you do it over the whole right side and over the whole left side. Not part, whole. The whole right side and the whole left side. Third root cancels out, so the y is alone. The other side is just third root of x minus 7. So there it is. Answer B on that. We good there? All right, so same 2 steps to find the inverse. Step 1, invert x and y. And this is the y out here. So we swap them, don't we? We switch these guys. So this is x over here, and that's y over there. So we just switch positions with x and y. That's the inverting. That's what we mean by an inverse function. X and y invert positions, switch positions. Okay, now step 2 is to solve for y. Now, what do we always do? Do you remember? When we have fractions with an equals. You put the x over 1, exactly. And then what? Cross multiply, right? Whenever we have fractions, put it over 1, diagonal, huh? So we go diagonal. X times y plus 8 is 1 times 9. Is that good? I just want diagonal. That's what we always do when we have a fraction on one side and just a whole number or whole letter on the other. Put it over 1, cross multiply. And what do we do now? With the parentheses, distribute. So we get xy plus 8x. And 1 times 9 is just 9. Now, y, there's the equal sign. I like to put that line in there, left side, right side. y, keep your eye on the ball, so to speak, right here. Here's the y. Y is yelling out, I want to be alone. Get rid of all this stuff that's with me on my side so that I can be alone. We're trying to solve for y. That's step 2, huh? So what do we do to start getting y alone? Yeah, subtract that 8x from both sides. Boom. And we get xy is 9 minus 8x. Last step to finish getting x alone. Or sorry, y alone. Divide by the x. And you do the whole right side by x. Don't you? Like that? Can I cancel those x's on the right side? Why not? Costco says no. There's pluses and minuses gluing them together. Right? Which means that 9 minus 8x is a package deal. You cancel all of it or none of it. We can't cancel all of it. Can't buy the whole package, so we buy nothing. Just leave it like that. That's our answer. 9 minus 8x over x. Is that there? No. Oh, careful. Let me bring it back. This is really good. We go. This is why I do a practice exam, because I really don't want to fool you on the real exam. Right. Let me get. Here's the answer we just got. We had 9 minus 8x over x. Yeah, which one of those is actually the same as that? 8. Yes, everybody see that's the same. How do we know? Because order doesn't matter. Signs in front matter. Remember? So if it has the order doesn't matter if it has the same signs in front. What sign? What's in front of this 8x? Negative. What's in front of this 8x? Negative. What's in front of this 9? Nothing, which is the same as positive. They're the same. So that's important. I don't want you to do all that good work. I want you to get the credit on that one. But that still is part of learning this language called algebra, is to understand when things are the same, although they might look different. Does everybody understand that so it won't fool you? Order doesn't matter. Signs in front matter. If they have the same signs in front, doesn't matter what order, they're the same. All right. On to number 3. Same thing. Want to find the inverse function. So number 3, so it'll be a little more, slightly more complex. Not a lot, but a little. 9x plus 2 over minus 4x minus 7. All right, you know, same 2 steps, right? Step number 1, invert or switch x and y. So this y out here will become an x, and the 2 x's both become y's, don't they? X's become y's, y's become x's. We good there? So now we need to solve for x. We need to solve for x. So how are we going to solve for x? What do we do when we have a fraction? I'm sorry, solve for y, not x. Solve for y. How do we solve when we have a fraction? Put it over 1 and cross multiply, huh? All right. Can you do that? So I'll do the next step. Cross multiply. And then we distribute. Boom, 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 boom. Like that. And then notice 2 of those terms have y. The minus 4xy and the 9y. Both those guys have y's in them, don't they? So what that means is you need to get those 2 on the same side and everything else on the other side. It doesn't matter, left side, right side, whatever. Just get the 2 y's on the 2 y terms on the same side. And get the other stuff to the other side. Remember, when you jump things over the equal sign, it switches the sign in front of it, doesn't it? So usually I put the y's on the left. It doesn't really matter. So I'll just, so let me say that. So they get the y's on the same side. So I'm going to take this guy and jump him that way. You could jump the minus 4x. I'm going to get the y's on the left, but you get them on the right. It doesn't matter. And I'll take this guy and jump him that way. It doesn't really matter. So then what do we have? minus 4xy minus 9y is 7x plus 2. Is that good so far? See how that minus 7x became a plus 7x when it jumped to the other side? Remember when things jump over the equal sign, like the cow jumps over the moon in the old nursery rhyme, when the things jump over the equal sign, it switches signs, doesn't it? And the plus 9y jumped over, became a minus 9y. We're really just subtracting 9y from both sides and adding 7x to both sides. I'm just skipping that step, right? Now, so get the y's on the same side, and now what do? Yeah, factor out the y, like with a big parenthesis. So take out the y. That leaves minus 4x minus 9. Everybody see that? Right? I just factored out that y. Greatest common factor, They both have a y. Try to get y alone. Now what do? Just divide. Divide by all that stuff. Now that y is in just one location, we can just divide by everything next to y. Boom. There we go. There's our answer. That's the inverse function. But I wonder if it's going to look like that or look a little different. Oh, it does. It looks just like that, doesn't it? Let's go. Let's take that answer back. So let me back up. What if I had gone the other way? Redo. If instead I got minus 4xy, here's the same, and 9y plus 2. Now, if instead I said, hey, I'm going to get the y's on the right side instead of the left, that's fine, doesn't matter. Then you can grab this guy and jump him over there, and you can grab this guy and jump him over there. It doesn't matter. Whatever. I'm getting the y's on the right side now instead of the left. It's all good. It doesn't matter. So what would we get in that case then? We would get minus 2 minus 7x, 9y plus 4xy. Everybody see that, right? When things jump to the other side, they switch their sign. And now it's the same step. Factor out the y, right? So get the y's on the same side. Got it. Step 2, factor out the y with the parenthesis. So that'd be 9 plus 4x, right? We good there? And last step, divide. Same thing. See how it's all just the same? I just got the y's on the right side instead of the left. Whatever. It's all good. Cancels out. This is the correct answer, but notice how it looks different. Let's take it back now and look. So minus 2 minus 7x. So going back to number 4. So, or 3. Minus 2 minus 7x over 4x plus 9. That's the answer I got. Do you see that's the same as this? Do you see that those are the same? How do you know? Well, would you recognize that on the test? I want you to be able to recognize that and not get fooled. So say you got this answer on the test. Would you recognize B is the same? How do we know B is the same? Well, look, if you take B here and you multiply, or take either one, take mine or take B and multiply by negative 1, boom, boom, 2 plus 7x over boom, boom, minus 4x minus 9. See that? 7x plus 2. Order doesn't matter. Signs matter, right? See how that's exactly the same? So if you have any answer and you multiply top by minus 1 and get something else, those are the same, really. Grab that option. Is that good? That is part of learning algebra, is learning the language. Any language you learn, part of learning that language is knowing when something's being said the same in a different way. Those are saying the same thing in a different way. Is that good? Anytime you can multiply top and bottom fraction by negative 1, grab it. Same thing. All right, on to number 4. If you don't have any questions, I'll move on to number 4. Find the slope. What's the formula for slope? Yeah, it might be a good one to put on your 3x5 card if you don't already have it memorized. y2 minus y1 over x2 minus x1, exactly. So this is x1, y1, x2, y2. Right? Remember how that works? First point's x and y, second point's x and y. So we go y2, negative 8, subtract y1, 5, over x2 negative 9 subtract x1 negative 2. So we have the subtractions in the formula, and then also some of the numbers are negative, right? Remember all that? And we got these double negatives down here on the bottom. Become positive, as you know. Minus 8 minus 5 over minus 9. Plus 2, that's minus 13 over, what's that, minus 7. Two negatives? Positive 13/7. There it is. So it wants us to find the equation. So we did a few of these. Remember these from the homework? Step 1 is you got to get your slope, huh? So that's the same thing it was a minute ago. Y2 minus Y1 over X2 minus X1. This is X1, Y1, X2, Y2. So Y2 minus Y1, which is minus 44, over X2, 8 minus X1, which is 9. So double negative there becomes positive. Minus 39 plus 44 over negative 1. What is that? 5 over negative 1? And what's positive over negative is negative 5. Are we good there with that slope so far at step 1? Right? So anytime you divide by 1, we don't leave a 1. And positive over negative is negative, so it's negative 5. Step 2, remember we write the slope formula again, but this time with the blanks at the back? Remember how this was my little, Heron's little method. I actually got it from a student many moons ago, and I thought that was a nice idea. He got it from some other teacher, who knows? But I think it's an easier way. It avoids fractions. So you won't see it this way on the little videos. They do it differently. Slope equals y minus blank over x minus blank. So we use the slope formula again, this time the easier way with the blanks. And we grab that slope we just worked hard to find, and we pop that in for the word slope. And then we grab an x and a y. Either pair, it doesn't really matter. It'll work either way. I'll just grab the first x and put it, careful though, make sure you put it behind x and the y behind y, and not vice versa, huh? So we get minus 5 equals y minus 44 over x minus 9. Remember all that? We'll do that a couple more times. And now what do we do when we have a fraction equal to a whole number? Over 1, cross multiply, huh? Diagonal, diagonal, that's right. Put it over 1, diagonal, diagonal. So we get minus 5 times x minus 9 equals 1 times y plus 44. Write that double negative there. And then we'll distribute. Boom, boom. So we'll get minus 5x plus 45. Boom, boom. Y plus 44. And then how do we finish getting y alone? That's always the deal. If you look back at the answers, that's the nice thing about multiple choice, huh? You know what they want. You don't have to guess. Looking back here at number 5. See how they all have y alone? So we think, oh, okay, yeah, I got to get y alone. So let's go back. Let's get y alone. So what do I do? The double negative right here. Made it plus. Yeah, good question. Double negative there made it plus. So remember, there's subtractions built right into the formula, and then if the number is also negative, double negative is positive. Subtract 44, we get minus 5x plus 1. So y is minus 5x plus 1, which is not there, is it? It's E, none of these, which is always a little disturbing, but here we go. Sometimes the answer is E. There'll be a few E's, not a lot, but a few. Questions on that one? 6, at 2 p.m., Emma left from home, and by 7 p.m., she'd gone 240 miles. What was her average speed in miles per hour? How do we figure out Emma's miles per hour? She left at 2, and by 7, she'd gone 240 miles. And they want miles per hour. What am I going to do? How many miles did she go? 240 miles. And how many hours was she driving to cover those? Over 5 hours, because she went from 2 to 7, huh? That's 5 hours. So 240 miles, but by 5 hours, isn't that 48 miles per hour? She averaged 48 miles every hour, which is answer A. Miles per hour means miles divided by hours, doesn't it? She covered 240 miles in 5 hours. Good there? On with number 7. In 1995, the United States recovered 21% of its municipal wastes through recycling, up from 17% in 1990. Let P represent the percentage recycled and T the number of years since 1990. Find a linear function, P of T, that fits this data. Use this function to predict the percentage recycled in 2007. Remember these? This was from chapter 4, 4.2, I think it was. These kind of problems. So, how are we going to do that? Well, I think if you're okay, I'm going to just erase this and just use that space, because I want to keep the words in front of us also. And I'll come up here for number 7. Here we go. Okay. And I'll say, okay, do you realize that what they're giving us is 2 points? They're saying 21% in 1995. Or I should 1995, 21%. See how they're saying T is the number of years since 1990? Like after 1990? So in 1995, that's 5 years after 1990, 21%. So that's 5, 21. Do you get that? And the next one, 17% in 1990. That's 0, 17. Where did I get the 0? 1990 is 0 years after 1990. And 1995 is 5 years later. See how I'm just listing the years and the percent? Everybody see that? It's really just like the problem we did right up there, still on the screen, number 5. They're basically giving me 2 points, and they want me to find the equation. It's just set into words. How are we doing? Does that make sense? Now, one of the things you might wonder is, well, how do you know, Mr. Tarrant, which one comes first? Well, see how down here it says P parenthesis T? Remember, it's usually f of x for functions, right? So whatever's in the parentheses is playing the role of x. You tracking with all that? So t is like our x. And x always comes first, so t must come first. Time must come first. The year must come first. Everybody see how I track that out? Time comes first. So, and you see why I put 5 and 0 instead of the whole 1995 and 1990? Because they said right here, T is however many years after 1990. So if it's 1995, that's 5 years after 1990. And if it's actually 1990, that's 0 years after 1990. Isn't it? At which time there was 17% recycling. So now that we have that, we just do exactly what we did on number 5. Step 1, find the slope. Step 2, use the slope equation again with the blanks and the cross multiply and solve for y. Right? It's exactly the same. This is just what we did in chapter 4. Wasn't easy. So step 1, slope. y2 minus y1 over x2 minus x1. This is x1, y1, x2, y2. So y2 minus y1, 17 minus 21 over 0 minus 5. That's minus 4 over minus 5. Double negatives cancel, plus 4/5. So the slope is positive 4/5. Step 2, we write the slope formula yet again. Y minus x minus with the blanks at the back. Grab the x. Just grab the first pair. You can grab either pair. I'll just grab the first pair, the 5 and the 21. Put them behind the x and the y. And grab that slope we just worked hard to get and plug it in for the word slope. So we have 4/5 equals, and this is going to be, and then I'll put the 21 behind the y and the 5 behind the x. Kind of running out of room here. So this is 4/5 is y minus 21 over x minus 5. Is that okay? I'm squishing that in kind of tiny. Can you see that okay? Like that? And then we're going to go diagonal, diagonal, aren't we? Cross multiply? Bring it up here. So we get 4 parenthesis x minus 5. 5 parenthesis y minus 21. Distribute the 4. Distribute the 5. 4x minus 20. 5y minus, I think it's 105. Y is saying what he's always saying, I want to be alone. So we got to get y alone. So what am I going to do to get y alone? Add the 105. Boom. So we get 5y is 4x plus, I think that's 85, isn't it? 105 minus 20. And then, last step to get y totally alone. Divide through by 5. So we get 4/5 x plus 85 divided by 5. Isn't that 17? Y equals 4/5 x plus 17. Now hold on. Hold on. They have, we're actually not done. That's a lot of work and we're still not done with this problem. Yeah, now we plug it in. You see this last part? Yeah, it says find a linear function. Use this function to predict the percentage recycled in 2007. So I want to use that equation that we just worked hard to get. How can that help us figure out the percentage recycled, in the year 2007? What do I do?
Counting years from 1990 to 2007.
Yeah, remember what T, good job, guys. See the T right here? It's the number of years since 1990. So you got to think, okay, if it's 2007, how many years is that after 1990? 17 years. 17 years. So that means X is 17. Plug in. Plug in X is 17 because 2007 minus 1990, whoops, I'm running out of room here, is 17, huh? Right? It's 2007 minus 1990 is 17. So that's 17 years later. So plug in. Now we got to go back. Plug in. We're almost done here. Take that 17. Plug it in right there for X. So we're going to go, okay, 4/5 times 17 plus 17. That's what Y will equal. Use your calculator. I'll use my calculator. Just take 4 divided by 5 times 17 plus 17. I'm getting 30.6. 30.6. There it is. Answer B. So look at that. That's kind of a impressive, somewhat sophisticated bit of mathematical work we just did. We were able to look at the pattern of how the United States is doing more and more recycling, how much they did in 1990, how much we did in 90 and then 95, how it went up, and then use that to predict, if it continues to grow in a linear fashion, the future, what would happen in 2007. Pretty sophisticated. Is that good? Questions on all that? It was a lot of work. 8. A gas station sells 48.20 gallons of regular unleaded gasoline on a day, when the average, when the charge is $1.35 per gallon, whereas they sell 38.50 gallons on a day that they charge $1.40 per gallon. So they go higher in price, and they sell less gas, right? The higher the price goes, the less people want to buy it. Find a linear function that expresses the gallons sold as a function of price. Do you see this is exactly like the last one? It's going to be a little easier, but basically the same thing. See how they're giving us 2 points again? Can you write down those 2 points? And when you write down the 2 points, how do you know which one comes first? Well, x always comes first, then y. Yeah, but we don't have x and y. Right. So far so good. X always comes first. Well, how do you know who x is? Well, when you write a function, isn't x what's inside the parentheses? Don't you write functions like that? F of x. So look what's inside the parentheses. What's inside the parentheses? P. So who's x? P. What is P? Price. So when you list the 2 points, put price first. See how I figured that out? Whatever's in the parentheses is always x, f of x. Or you can just say whatever letter's on the right side, that's x. That P is playing the role of x, isn't it? The P is x. The price has to come first. The price, right there, there's price. The price is like the x. So it has to be price and then gallons, doesn't it? So I'm going to say, okay, $1.35, that's what, 48.20 gallons, and $1.40 is 38.50 gallons. See how I'm putting price first? That's the opposite order they put them in the words. But we know we need that order because of how they wrote those equations. Price first, comma gallons. All right, you know what to do, right? Find the slope between those. Rewrite the slope formula the second time with the blanks in the back. So I'll jump back and do that too. Move this up here. So step 1, slope, y2 minus y1 over x2 minus x1. So y2, 38.50 minus y1, 48.20 over x2, $1.40 minus x1, $1.35. Those are big numbers. Use your calculator. No, they just want the equation this time. So we'll see. So this is 0.05, right? And then if you divide that, or you could just leave it. Maybe that'd be easier. All right, maybe we better divide. I'll just divide it. So I'm getting minus 19,400. You guys get that when you divide? Minus 19,400. No, that's our slope. And then step 2, now we write the slope formula again, this time with the blanks at the back. I'm going to grab the first pair, put the x behind the x, and the y behind the y. Right? And then grab that slope we just worked hard to find. Put that over here. So minus 19,400 over 1. And then cross multiply. So diagonal, diagonal. Minus 19,400. X minus 1.35. Y minus 4820. We're good to there. And now we distribute. So minus 19,400x plus, negative times negative, and just use your calculator, 1.35 times 19,400. I'm getting 26,190. Distribute y minus 4820. Last step to get y alone. Add the 4820, right? Boom. So y will equal minus 19,400x plus, what is that? My calculator says 31,010. And that's answer D, isn't it? On the multiple choice there. At least on the one I'm listed, it'll randomize it for each of you. Number 9, Daniel is saving money to purchase a home. The amount he has saved in his account in thousands of dollars is A equals 5 plus 3t, where t is the number of years after 2020. There we go again with that. You know, they have a starting time that's so common. Biology, chemistry, you take those kind of things, do this all the time. Starting time is 2020. T is years after 2020. In what year will he have saved the $26,000 he needs for the down payment on a home? All right, so let's do it. Let's crank it out. So we're going to write A equals 5 plus 3t. So how do we do this problem?
26,000 is supposed to be A.
Good. That's right. Good job, guys. Good job. Yeah, it's all about the fact that they're telling us the 26,000 is the amount he saved, right? Now, the question is, let's watch this carefully. Here's the part that gets people. Everybody feeling alert, watching this closely? Should I plug in 26,000 or just 26 for A? It's not a matter of opinion. Read these words very carefully. Right, because it's already in thousands. Does that make sense? And that happens any science thing, when they say, hey, we're already in thousands. You know, just be real life with me for a minute. If I said, hey guys, I want to tell you about what it takes on a down payment of a house, I'm talking thousands now. If I say that sentence, and then I go 26, you know, I don't mean $26, I mean 26,000, because I just said I'm talking thousands now, right? So that's all they're doing. They're just being real like that. They're saying it's in thousands. It's already in thousands. So that's the mistake I see a lot of people make. You don't need 26,000, you just need 26, huh? It's already in thousands. Yeah, so we plug that in. That's the amount, that's the A. He needs 26,000, and we want to find T, how much time until he has that amount saved. So I just need to solve that little equation for T, right? What's my first step to solve for T? Subtract that 5, exactly. Boom, 26 minus 5 is 21. Last step to solve for T. Divide by the 3. T is 7. So what year? 2027, because remember, it's after, T is the number of years after 2020. So that means in the year 2027, he'll have that money saved. Lots of graphs on this one. Number 10, okay, the slope of the above line. Now, how do we take a line like that and find its slope? 2 points, huh? Wait, so you want to find places where it clearly crosses grid marks. Like how about right there? Is that good? This isn't a very good graph, is it? I don't know why it didn't all show up very well on the graph. Better on yours? That's not great either, huh? Okay, so we've got to be kind of careful here. And they're only going by 2s, so we got to be careful. Okay, so anyway, we're going from there, and let's find another point that's at a clear hash mark, like there. Does that look good? Those are on really clear where grid lines cross, right? All right, so that's over how far? 2, right? Because that goes over to 2 here. Yeah, good. And then how far down? 2, 4, 6, 8. Down 8. Because those are going by 2s, aren't they? Everybody see that? See how it goes right to, because every jump from line to line is 2 on that graph, isn't it? So right 2 down 2, 4, 6, 8. So right 2 down 8. So the slope, remember, is rise over run. What's the rise? -8. What's the run? 2. -4. Boom. Remember graphing. Remember all that day we spent 3 hours graphing these x squared equations? So here they are. So how do you graph an x squared, U-shaped, parabola, quadratic, whatever you want to call it? Quadratic, parabola, same thing.
Is this opposite same thing?
Almost. That's when there's parentheses. We'll get to that. Like, let's look, I'll show you one of those. That would be like that one. See, number 13's got the parentheses. That's when you do opposite same. Number 11 and 12, they don't have, or 11 here, they don't have parentheses. So when they don't have parentheses, remember we got to find the center of that U shape, and we had a little formula for finding the center of the U shape. Anybody remember it? -b over 2a. Yeah, it's the outside of the quadratic formula. Let me write this a little bigger for you here. -2x squared plus 4x plus 1. Yeah, so you identify this is the A, the B, and the C, right? And then, yeah, we learned that x, for the center of the U shape, what's it called? The vertex of the U shape, the center, it's -b over 2a, which is like how the quadratic formula begins, except for the plus or minus root part, huh? So put that on your 3x5 card. You don't want to show up at the exam without it, like they said about American Express or whatever. You don't want to leave town without it. You don't want to show up at the exam without that on your 3x5 card. -b over 2a. Right? So this is -4 over 2 times a, -2. Let me move that up a little bit. So it's -b over 2 times a. That's -4 over -4, positive 1. So x is positive 1. So that's the x value. Now we need to find the y value. How do you find the y value? Now you plug that 1 in, remember? So now I go back and go, okay, I've got x. X is 1. So now I take y equals minus 2x squared plus 4x plus 1, and I plug in that 1. Remember, when you plug into a function, you put parentheses around whatever you're plugging in. And so what do we get? Minus 2 plus 4 plus 1. Y, isn't that 3? So in other words, the center of the U shape should be 1, 3, x, y, 1, 3. Which of those 4 U shapes has a center at 1, 3? A, B, C, or D?
A.
Boom, we're done. It's A, huh? Right 1, right there. Right 1, up 3, answer A. And it's a U-shape going down. What makes it go down? The negative 2 in the very front. But they all do that. So yeah, there it is. Yeah, that's the only correct one. Write 1 up 3. Is that good? And notice I don't put in none of the above on these graph ones. So you know it's one of those 4. Number 12 is another U-shape. But this time they're giving me x-intercepts and a y-intercept. Different kind of information. Remember how this works? We learned a lot that graph. What's that? This, not quite. This is where we do opposite, though. We have x opposite. Remember, it's y equals, and there's an a in the front. Hope I'm not doing this very well. It's x opposite and x opposite. How are we doing? Is that good? Remember that? You take these two x values. Remember, it's the opposite of the x-intercepts. They're called roots or zeros. Remember all those names? X-intercept, roots, or zeros. They're called zeros because they're at a height of 0. They're x-intercepts because they hit the x-axis. They're roots. I don't know why they call them roots. It just has to do with the solution. They're the solution to an equation. So they go by those names, roots or zeros or x-intercepts. So we put them opposite. So the opposite of -1, +1. The opposite of +4, -4. Good so far? Now, how do we find the A? You can tell it's either 2/3 or 3/4, or maybe it's none of these. How do we find the A? The number that goes in the front. Right? The y-intercept. Exactly. Now we use the y. Right? We've used the two x-intercepts already. They're done. Now we have to use this y-intercept. Because that's right here. That's this point over 0 up 3. X is 0, y is 3. That's a point on the graph. That's on the U-shape, isn't it? Anytime you have a point on a graph, any graph, not just U-shapes, but any graph, that means if you plugged in the number for x and the number for y, it's got to make the equation true. That's how it gets to be on the graph. That's why that dot's on the graph. That's the membership requirement. You get in the club if you make the equation true. Right? So plug in 0 for x. At the same time, plug in 3 for y. So 3 equals a times 0 plus 1 times 0 minus 4. Does everybody see that? So step 1 is right here with the opposite x thing. Step 2, plug in 0, 3, x is 0, y 3, the y-intercept. And find A. Solve for A. Solve for A. Okay, so how do I solve that for A? Well, this is 3 equals A times 1 times -4. That's 3. 1 times -4 is just -4. How do you finish solving for A there? I'm going to divide, by -4. Boom. So A is -3/4. So the real formula, so put that in right there. That's what goes in the front. -3/4, x plus 1, x minus 4. It's C, isn't it?
So for the x values, you change them to the opposite, but to the y value, you keep it the same.
Right.
Okay.
Right. We good there? Remember that? Is that coming back? It's all the stuff we did in homework back in beginning of chapter 5.1, I think it was. Yeah. You remember what Faith's remembering. That is, you got to do opposite same. Yeah, you don't have to mess with the big hard formula if you remember that shortcut, or better, if you have it on your 3x5 card. So let me write this out a little bigger for you. Yeah, so what we do on this one, when there's parentheses, you can just go opposite. Again, see how it's always opposite for x? Always opposite for x, Whatever's in the parentheses next to x, always opposite. And then same. for a number out there. So that would be x equals -1. Y is -1 also because it's the same. So it's -1, negative. What is? That's the center. That's the center of the U shape. -1, -1. You just take opposite of what's next to x in the parentheses. And then the same as the number off to the right. So which one of those four, A, B, C, or D, has a center that's -1, -1? A and C both do. Uh-oh. So we're done with these two, but we're down to A and C now, aren't we? Now, what's the difference between A and C? They both look very similar. Can you see any difference?
One of them is thinner than the other.
Yeah, C is a little thinner. A goes out a little wider. So how do you know which one's right? Yeah, remember the number in the very front is like a slope. It's a rise over run. Remember this? Rise over run from the center. Right, remember that? Rise over run. So we have to start from the center right here, and you should go up to right 1, and you should hit another dot on the U shape. See, if I go up 2 over 1, I hit right there. No, that's not hitting it. It misses that. I don't know if you can see that. And up 2 over 1, beautiful. C hits it perfect. See how from the center on C, if you go up 2, right 1, perfect. You land right on another dot on the U shape. But with A, you barely miss it. Can everybody see that? From A, if you go up 2, right 1, you're on the axis, and the U shape doesn't quite hit that point. Whereas on C, up 2, right 1, the U shape goes right through it. C is our answer. So you remember all that stuff? So that's when you have parentheses squared. So you should put on your 3x5 card. When you have parentheses squared is when you can just do opposite same to grab the center. You don't have to do the -b over 2a formula. And then the slope at the front. So you see a lot of success in math and science is putting in the hard work of being organized. Right? You with me? And to help you. See number 13. So parentheses squared. You got to do that. Back on number 11. No parentheses squared. See the difference? This is what you need to do for yourself. I'm trying to do all I can with the time we have. No parentheses squared. So then you have to use the -b over 2a. See the difference? I'll do the same thing on the real test coming up. I'll give you one with no parentheses squared. So there's no parentheses there. So you got to do the -b over 2a. And then I'll give you one with parentheses squared, right, where you can just do opposite same on that. So number 14. An object is thrown upward from the top of a hill. The height of the object, h, is h after t seconds, according to that formula. When will the object hit the ground? So h equals minus 16t squared plus 98t plus 12. Okay, so how are we going to do that? When will the object hit the ground? How do we figure that out? Got a plan?
I can't exactly remember the name of it, but the -b plus or minus the square root of...
Well, let's think about what it means for an object to hit the ground. Remember, this is going to, what kind of graph is this? If we were to go, I'm not going to do the whole graph, but x squared means it's a U-shaped graph, right? T squared, x squared, whatever, same thing. It's a U-shaped graph. Is it a U going up or a U going down? Down, because it's negative in the front. And that makes sense, right? When you throw a ball or throw anything, right, it goes like an upside down U shape. Of course, that graph is an upside down U shape. Now they're asking us about when it hits the ground. So what do we know at the moment that ball hits the ground? What is 0? Height is 0. H is 0, right? When the ball hits the ground, its height is 0, isn't it? H equals 0. So that means I take this equation and I go, bonk, I put a 0 in for H, don't I? And I solve that equation. So I go, oh, okay, so 0 equals minus 16t squared plus 98t plus 12. Now, how do you solve that equation? The quadratic formula. Remember, x squared equations are solved by the quadratic formula. So we got to use that. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And so here we go. So negative b, negative 98 plus or minus the square root of b squared, 98 squared, minus 4 times a, I'm running out of room there, times c. What's c? 12. Everybody all over 2a. Remember all this stuff? This is a, b, c. So I plugged into the quad. Let's bring it over here. So that's minus 98 plus or minus the square root. Take your calculator and make sure you have a good calculator. Don't show up at the exam without a calculator that you're used to using. There'll be no way to succeed without that. And then now watch the signs here. Negative times negative, positive. 768 all over negative 32. And this will be minus 98 plus or minus the square root. I don't know what that is. Let's use my calculator here. I'm getting 10,372 all over negative 32. And so really you just have to do the two different options. So one of them is going to be minus 98 plus the square root of 10,372 all over minus 32. The other one is going to be minus 98 minus the square root of 10,372 all over minus 32, right? So crank those out. Now make sure on your calculator, 6.245. Make sure when you do this, make sure you guys have your calculators. Make sure you remember to hit equals when you're done with the numerator before you hit divide by the negative 32. And make sure you know how to do negative on the 32. So the other one, let me see how I get 98 plus square root of 10,372. I'm getting, this other one I get negative 0.12. That's a baloney answer because that's back in time, right? Negative time, that can't happen. Math goes beyond reality. So the real answer is this, 6.245. So is it this answer? Yeah, now a lot of times students have asked me, they go, well, Mr. Aaron, it didn't say round. Well, yeah, it doesn't always happen. When you take math and science tests, they won't always say round. But you just grab the same answer if it rounds the same, right? If I rounded that to two places, it would be exactly the same thing, wouldn't it? It would round to 6.25, right? That 4, look one to the right, would round. So there's the answer.